this session, we are going to discuss about reducible equations. What does reducible equations mean? Sometimes when you observe the equations are given in a very straightforward form, like x plus y is equal to 1. You know two unknowns very clearly, but when you see some kind of equations like this one, x plus 2y is equal to 21xy. If you see on RHS side, x and y is given as a product. We have not dealt with this kind of situations so far. So we need to do some manipulations first. So whenever we need to do manipulations, those kind of equations are called as reducible equations. We are going to reduce to some other form. That is the reason it is called as a reducible equations. Maybe it can be square root, maybe it can be any kind of polynomial x plus y, right? So we are going to discuss each case one by one. So let's start with this case. So x plus 2y is equal to 21xy is given. Now what kind of any manipulations we can do over here? Think about it. What can we do it? I am having one idea that what kind of manipulation I can do. So you can also think for a while that x plus 2y is equal to 21xy, how to do it. This sum is not out of syllabus, it is of the same case. We just need to change its form, right? Then we will solve it and again we will convert into original form. So that is the steps I have written. First of all, we are going to assume the variables as a, b, p, q, m, n, u, v, any of it. Then we are going to solve it and afterwards we are going to substitute the assumptions, right? Same, changing the form, solve it and again go back to the original position from where we started. So let's start this equation. Let's start the solution. So how do we do it? What I will suggest is, first we need to divide what we want to remove, this x and y as a product. When two variables are coming as a product, it is very difficult to eliminate them. So I am going to eliminate both of them, right? I will be dividing every term by x and y. Let's say I want to divide x and y over here. So I am dividing with x and y. But make sure you need to do same for each and every term. You cannot do for only one term. You need to do for all of them. So I will divide over here as well and here as well. Second equation is also of the same form. So I am going to repeat the same steps, which is divide by xy, divide by xy, and here also divide by xy. So let's simplify it. X will get cancelled, y will get cancelled, and xy here and xy here. See, xy is completely removed over here. Here xx, y and xy completely gone. So what's left? Remember, there is nothing in numerator right now. X was there, but it has been cancelled out. So don't even by mistake write y in numerator. Don't do it. Keep y in denominator, and if there is nothing, we always write it as a 1. So plus here it is 2 and in denominator, which is x, here 21. Let's write this equation. There is nothing in numerator, so I told you 1 over y plus 4 in numerator and x in denominator, and here which is 27. So there is no x and y product anywhere in this equation, but we have one more problem. 1 upon y and 1 upon x, 1 upon y, 1 upon x. So we are, if you observe, there is a pattern. 1 over y, it is there in both of the equations, and 1 upon x is also there in both of the equations, right? They are in the same form, they are repeated. So what will I do? I will assume as 1 upon x is equal to m and 1 upon y is equal to n. So wherever I see 1 upon y, what I will be replacing with? N. And wherever I see 1 upon x, I will be replacing with m. Simple, right? So you can see this equation, 1 upon y is there. So what will I write? N plus 2 upon x. So how will you write this equation? Remember, you can write this form as 2 multiply by 1 upon x, right? Remember, both means same, right? This is more simpler form, 2 over x. So 2 multiply by 1 upon x. Now we know 1 upon x, what we will write? M. So 2 as it is, and instead of 1 upon x, I will be writing m is equal to 21. So this is my first equation. You can write second one as well, easy to do. 1 upon y means what? N, simple, and 4 upon x. So I can just write in a detailed step, 4 multiply by 1 upon x. So 4 will remain as it is. Instead of 1 upon x, I will be writing what? M. So is equal to 27. So right now I have two equations in much simpler form than I started with. There were two variables in multiplication, then in fraction, right? I don't have any of such situations right now in front of me. So what I need to do, I need to solve these two equations. You can choose again out of 4 any method, graphical, substitution, elimination, or cross multiplication method, and you can get the value of n and m, right? So you get the value, then verify what value I am getting with. Okay, so let's solve this two equation. You can see whenever there are same coefficients, only method I suggest is elimination method, right? Very simple to do. N coefficient 1, this n coefficient 1, right? So same coefficient, let me write this equation over here. So n plus 4m is equal to 27, right? Now if same coefficients are there, okay, first step is done. If same signs are there, what do? We subtract it. So I am going to subtract these two equations. This is positive n will become negative, this positive 4m will become negative, my plus 27, that will become negative. So this n get cancelled, plus 2m and plus 4m. Remember, this minus sign is of this term. This was old sign that we are not supposed to consider. So plus 2m and minus 4m, that will give you minus 2m is equal to 21 and minus 27. So this is a case of subtraction. So that will be minus 6. Let's get the value of m. M is equal to minus 6. This 2 will go into denominator. Minus minus plus, 1s and 3s. So what's the value of m? Which is 3. My value of m is here. Now guess what? What will I do? I'll substitute the value of m into, yes, any of the equation and get the value of another variable. Let's get the value of n. So n as it is plus 4 into value of m, which is 3, is equal to 27. N plus 12 is equal to 27. I will be shifting this plus 12 over this side, so it will become negative. N is equal to 27 minus 12. So n is equal to 7 minus 2, 5, 2 minus 1, 1. So value of n is 15, right? So let's discuss step what we have done so far. First of all, assume the variables. I have done. What are my assumptions? 1 over x is equal to m, 1 over y is equal to n. So this is my step 1, right? Afterwards, solve the equations. Where is my solution? This one. So this is my step 2. M is equal to 3, n is equal to 15. Third step, substitute the values in assumptions. So I am going to go to the point where I started with. I started with this one. So I am repeating this same step over here. Let me give number 3 for the third step. So 1 over x is equal to m and 1 over y is equal to n. So 1 over x as it is, and what is the value of m, which is 3, and what is the value of n, which is 15. So now how to do? This is not our final answer. Okay, this is not our final answer. We want value of x. We don't want value of 1 upon x. So what kind of manipulation can we do here still? You must have learned about the reciprocal, right? This denominator will go up and numerator will come down. So that I am going to do over here. But you will get confused that 3 and 15 is not having any kind of denominator. Remember rational numbers. Whenever there is no denominator, there is always 1, right? So I can write it as a 3 over 1 and 15 over 1. So if I do reciprocal now, this will become x over 1 and 1 over 3, and here y over 1 is equal to 1 over 15. So my solution is x is equal to 1 upon 3 and y is equal to 1 upon 15. This is my final answer is. If you are stopping your sum at this point, you have not got the final answer. Your sum is correct, but that is not the final answer, right? So this was our third step. Let's repeat the method one more time. So first of all, what we did, we divided with x and y, each term one by one. Do not ignore RHS, right? That we will only divide LHS and ignore the RHS. That will not give you the correct answer. So afterwards we got the equation in fraction form, 1 upon y plus 2 upon x is equal to 21, and I have assumed some of the values of 1 upon x and 1 upon y based on the pattern you are getting, right? 1 upon y is there in both of them, 1 upon x is in both of them. That's why here it is not possible to assume the value. So m and n, after substituting, you can choose any of the 4 methods to solve the equations. So the second step is solving the equations. M is equal to 3 and n is equal to 15. Afterwards, third step, I am going to substitute the values in assumptions. Where I started, I am going to put the same value in that equations, which is 1 upon x is equal to m and 1 upon y is equal to n. So 1 over x is equal to 3 and 1 over y is equal to 15. Remember, you need to take reciprocal here. Then only you will get value of x and y. So my solution is x is equal to 1 upon 3 and y is equal to 1 upon 3. So this was first case of reducible equations. We are going to solve another case of reducible equation. So let's discuss second example of reducible equations. So imagine what order we will take or what assumptions we will take in this case. So question is 2 over square root of x plus 3 over square root of y is equal to 2 and 4 over square root of x minus 9 over square root of y is equal to minus 1. I told you in previous example that you need to identify one common pattern. In previous example, we divided with x and y each and every term because there was not any kind of identifiable pattern. You can see over here that 1 over square root of x and square root of y, it is common in both of them, right? So I can take 1 over square root of x is equal to a and 1 over square root of y is equal to b. So my first step is done, right? So I am going to substitute these values over here. So let me simplify it. So 2 multiplied by 1 over square root of x plus 3 multiplied by 1 over square root of y is equal to 2. This is for the first equation. Let's do for second. 4 multiplied by 1 over square root of x minus 9 multiplied by 1 over square root of y is equal to minus 1. So let's put these values of a and b. So this will be 2a plus 3b is equal to 2 and here 4a minus 9b is equal to minus 1. So we have equations in simple form, not any kind of fractions, not any kind of surds. So 2a plus 3b is equal to 2 and 4a minus 9b is equal to minus 1. Now we have four methods to find the solution of these equations. So you can choose graphical method, you can choose substitution method, elimination method, or cross multiplication method. So if you want to choose any one of it, you are free to do it. Answer is going to remain same. So suppose if I want to do elimination method in this case, right? So what I will be first of all judging, that is coefficients of a and b. So let's talk about coefficients, which is here 2 and 4, 3 and minus 9. Now observe the sign of the coefficient as well, which is plus 3 and minus. So opposite signs are already with us. Okay, so I will be modifying the first equation. What will I be doing? Let me just write this second equation below it, so you will get clear idea. 4a minus 9b is equal to minus 1. This is what I am interested in. Plus and minus, they will cancel out each other if we have equal coefficients. That we are not having now, so we need to multiply with some numbers. So minus 9 and plus 3. So I can multiply with 3 over here, so I can get plus 9b. So let's do. I will be multiplying 3 with each term one by one. Remember, do not skip any term even by mistake. Most importantly, RHS. So if I write this, if I multiply this, I will be getting as 6a, 3 into 3, that will be plus 9b is equal to 3 2s are 6. So let me simplify it. I will be adding over here because minus 9 and plus 9, they all are ready here. So we can just cancel out minus 9b and plus 9b, cancel. 4 and 6, that will be 10a. Here equal to minus 1 and 6. Follow simple rules of integers, simple calculations. So that will be 5. So if I want value of a, that will be 5 and 10 will go into denominator. So that is a is equal to 1 over 2. So that is my solution for a. Now I want value of b. So you can substitute this value of a in any of the equations. I am substituting over here. So for value of a, which is 1 over 2, minus 9b is equal to minus 1. So you can cancel 2 1s are 2 2s are. 2 into 1, that will be 2, minus 9b is equal to minus 1. So right now we have equation in one variable. There is only b in whole equation, no a. So it is simple to solve it. I will be shifting this 2 over this side. Minus 9b is equal to minus 1, and if I shift this 2 over that side, that will become what? Negative. Yes. So minus 9b is equal to minus 3, and as I want value of b, I will be taking minus 9 in denominator. So minus 3 over minus 9. Two negatives will make positive. 3 1s are, 3 3s are. So b is equal to 1 over 3. So my solution for b is 1 over 3. Remember, this is not my final answer. These are the values of a and b, but what I want, values of x and y. So my second step is over here. Let me do the third step, which is last. I am going to substitute this value in assumptions. So 1 over square root of x is equal to a, and 1 over square root of y is equal to b. So 1 over square root of x. What is the value of a? Which is 1 over 2, and 1 over root y is equal to, what is the value of b? Which is 1 over 3. So I will be doing reciprocal like we did in previous case. So denominator will go up and numerator will come down. So this is root x and this is only 2, and this is only root y, and here 3. Still we don't have value of x and y. We don't need to get only square root of x. We want x. So to remove this third, we are going to square on both of the sides. So you can write squaring on both sides. So this is square root of x whole square, 2 whole square, and square root of y whole square is equal to 3 whole square. So here it is simple x, here it is 4, and here it is y, and then it is 3 square, which is 9. So my final solution is x is equal to 4 and y is equal to 9. So this is how we do reducible equations. We are going to discuss third example as well. So let's discuss third example for reducible equations. First of all, identify if there is any kind of patterns for variables. Here 3x plus y, 3x minus y, and 3x plus y again, and 3x minus y again. So you can see there is an identifiable pattern over here. So we need to catch it, and we are going to replace with some other variables. So 3x plus y and 3x minus y. So it is very confusing what we are going to assume. So think about it, how we will start with this sum. The first step is assume the variables as a, b, p, q. Now variables depends on you, but how do you assume it? That's very important, right? 3x plus y and 3x minus y. Now what I will suggest here is, see, there is a 1 over 3x plus y and 1 upon 2 into 3x plus y. So this complete fraction is there, that being repeated, 1 over 3x plus y and 1 over 3x minus y. So we are going to replace that with some other variables. So let's start with the first step. So 1 over 3x plus y is equal to u, and 1 over 3x minus y is equal to v, right? So let's replace it. 1 over 3x plus y I am going to write as u, plus 1 over 3x minus y I am going to write as v. So that will be v, and 3 over 4 as it is. No change on RHS side because it is only numbers. Let's do for second equation. That will be u over 2 minus v over 2 is equal to minus 1 over 8. Now we have fractions, so we are not going to solve this in a direct manner. We need to first of all resolve these fractions, get in the form of whole numbers, then only we can solve it. So how will you do that? I think we have discussed this, how to remove these fractions. So we'll take LCM of denominators. In this case it is only u, v and 3 upon 4. So very simple. We will multiply the whole equation with LCM, which is 4. So I can write multiply by 4. Each and every term I am going to multiply. Most importantly, do not forget the RHS, right? So 4 into u, that will give you 4u plus 4v, and here see 4 multiplied by 3 over 4. This will get cancelled. Only 3 will be left. Okay, let's talk about this side. 2, 2, 8. 8 is a multiple of 2. So LCM is 8. I am going to multiply with whole equation with 8. Again, each and every term. Do not skip any of the term by mistake, right? So 8 multiplied by u over 2 minus 8 multiplied by v over 2 is equal to 8 multiplied by minus 1 over 8. Okay, let's do cancellation. 2 ones are and 4s are, 2 ones are, 4s are, 8 ones are will get cancelled. So let's write simplified form, which is 4u plus 4v is equal to only 3, my first equation, and second, that is again 4u minus 4v is equal to minus 1. So now observe, again we have 4 options to choose from: graphical, substitution, elimination and cross multiplication. Which method we can use to solve these two equations? Remember, we started with fractions x and y and we have u and v. We are going to get this solution for u and v. So I believe that see the coefficients. Very good thing about these equations: 4, again 4u plus 4v minus 4v, right? Opposite sign, please eliminate them first. Very easy to do. So I'm going to write this equation below over here. So which is 4u minus 4v is equal to minus 1, and I'm simply going to add it. Let's see what's left. Plus 4v minus 4v, that will get cancelled. 4 and 4, that is what? 8u is equal to 3 minus 1, simple calculation, which is 2. So value of u is 2 over 8. If I do cancellation, which is 1 over 4. So my value of u is 1 over 4. That is my solution for u. Now let's substitute the value of u in this equation and let's get the value of v. So 4 into 1 over 4 minus 4v is equal to minus 1. So again this 4 will get cancelled. So only 1 minus 4v is equal to minus 1. Let's shift this 1 over that side. So it will become negative. Minus 4v is equal to minus 1. And this 1 will come over RHS and it will become negative. So which is again minus 1. So minus 4v is equal to minus 2. So v is equal to minus 2 over minus 4. So if we do cancellation, that is negative and negative will make positive, and after cancellation v is equal to 1 over 2 is my solution. So I have value of u and v with me. Remember, what I am looking for is x and y. Okay, we do want to find the value of x and y. So let's substitute it and get the answer. So let's start with this one. 1 over 3x plus y is equal to u, and 1 over 3x minus y is equal to v. So what is value of u? Which is 1 over 4. So 1 upon 3x plus y is equal to 1 upon 4, and 1 upon 3x minus y is equal to 1 over 2. Now see that we have 1, 1, 1 in numerator in each case. So let's take reciprocal. Denominator will go up in all cases, numerator will come down. So 3x plus y is equal to 4. This is equation, this is not solution. In previous case, we were getting the direct answer after we take reciprocal, but here still we are getting equations, so we need to solve it. Here we will get another equation. See, 3x minus y is equal to 2. See, 3x plus y is equal to 4 and 3x minus y is equal to 2. So we are not getting direct answer for x and y. we still need to solve these two equations to get the answer. So let me just write this below it. You'll get an idea that which method are we going to use, which is 3x then minus y is equal to 2, right? Elimination method, because this is plus y and minus y, so that will cancel out each other. So what's left? 3 and 3, that is 6x here, 4 and 2, which is 6. So if I want value of x, which is 6 over 6, so x is equal to 1. That is my final solution. I need value of y. So I'm going to substitute this value of x in this equation. 3x minus y is equal to 2. Let me rewrite. 3x minus y is equal to 2. X is equal to 1. I'm going to substitute in this equation. So 3 into 1 minus y is equal to 2. So 3 minus y is equal to 2. I will be shifting this minus 3 over this side, so it will become minus 3. So minus y is equal to 2 minus 3. Simple calculations, minus y is equal to minus 1. And this both negative will become positive. So plus y and plus 1. So solution for y is 1. So my final solution is x is equal to 1 and y is equal to 1. So this is how we solve equations when it is given in another form, not directly which is given in the form of x and y, but we convert into other forms, then we solve the equations, then we substitute the values. So these kind of equations are called as reducible equations.